What is probability distribution? Probability distribution is any rule that assigns probabilities to each of the possible value or values of a random variable. Any rule that assigns probabilities to each of the possible values of a random variable, that is said to be probability distribution. I repeat, probability distribution is any rule that assigns probabilities to each of the possible values of a random variable. Now, what are the various terminologies associated with probability distribution? Definition of terms. Number one term I'm going to examine is random variables. Random variables. Random variable is a variable that takes different values. A variable that takes different values as a result of the outcomes of a random experiment. A variable that takes a different value or that take different values as a result of the outcome of a random experiment. That is random variable. A random variable is a variable that takes different values as a result of the outcome of a random experiment. Number two, I want to know that probability distribution may either be classified as a discrete probability distribution or continuous probability distribution. So what do you mean by discrete? Discrete probability. Discrete probability. Discrete probability is the probability that allows to take a limited number of values. Any probability that is allowed, the one that is allowed to take a limited number of values. I repeat, the probability that is allowed to take the limited number of values is said to be what? A discrete probability. It's allowed to take a limited number. There is a limit to its number. So that is discrete probability. Then the next one is continuous probability. Continuous probability. Continuous probability. Continuous probability distribution is the probability distribution that is permitted to take any value within a range. The probability distribution that is permitted to take any value within what? Within a range where there is a range of numbers. The one that is permitted to take value, any value from that range of numbers. Binomials. Probability distribution. Binomials probability distribution is a discrete probability distribution. A discrete probability distribution arising from a situation in which there are two possible outcomes, favorable and unfavorable. A discrete probability distribution, a discrete probability distribution which arises from two possible situations in which one of the situations is unfavorable and the other is favorable. One unfavorable, the other is favorable. Let P be the probability of success in any single Bernoulli trial. If P equal to probability of success, probability of success means probability that an event will happen. P is the probability of success. That is probability that an event will happen. Q is probability of failure. Probability of failure means probability that the event will not happen. P is probability of success, while Q is probability of failure. P plus Q is equal to 1. I want you to take note of this. P plus Q equal to 1. If P plus Q equal to 1, therefore Q will be equal to 1 minus P, where probability of success is given. To get the probability of failure, you subtract probability of success from 1. 1 minus probability of success. That will give you the probability of failure. In N trial, the probability that the event will happen in X time is given by, in N trial, the probability that an event will happen in X time is equal to N combination X, P raised to power X, and Q raised to power N minus X. This is the formula for solving binomial probability distribution. Probability that event X will happen in any given binomial trial, N trial, is N combination X, P raised to power X, Q raised to power N minus X. X denotes number of sources in N trial. That means X could be number from 0, 1, 2, 3 to N, which means that your X could be less than or equal to N, but X cannot be greater than N. It cannot be greater than N. So, remember, a random variable is a variable having the same distribution. Remember, a binomial or a binomial distribution is a random variable having the same distribution. Any random variable that is having the same distribution is said to be a binomial or binomial distributed. Example 1. Find the probability of getting exactly 2 heads in 6 tosses of a fair coin. Probability of having exactly 2 heads in 6 tosses. 6, that is N. 2 heads, that is X. Solution. If you toss a coin, the possible outcome is could either show a head or a tail. That is possible outcome. Tossing a coin, you may have head or tails. This is 1 head, 1 tail, making 2. Probability of having heads, probability of having head. If a head is showing up, is 1 over 2. And probability of a tail is also 1 over 2. So if 1 over 2 is the probability of success, our P is 1 over 2. Therefore, Q will be 1 minus 1 over 2. I've told you that Q equal to 1 minus P. If Q is 1 minus P, therefore Q will be 1 minus 1 over 2. 1 minus 1 over 2 will be 1 over 2 if you simplify this. That means P is 1 over 2 and Q is also 1 over 2. I've told you that in a given binomial trial, probability of event X to happen will be equal to N combination X, P raised to power X, and Q raised to power N minus X. Now, the number of trial or tosses, we have 6 tosses of a fair coin. That means our N is 6. If N is 6, X is, you are having exactly 2 heads. X is 2. Now let's substitute into the formula. We have probability of X equal to 2. If you are having 2 heads, equals to N. Our N is 6. Combination X. S is 2. P. Our P is 1 over 2. 1 over 2 raised to power X. X is 2. Multiply by Q. Q is also 1 over 2. raised to power n minus x. N is 6, while x is 2. 6 minus 2. So we have, remember, 6 combination 2, that is 6 factorial over 6 minus 2 factorial and 2 factorial way. For better understanding, if you want to learn more about combination, try to watch my videos. The videos I have on permutation and combination. We have 6 factorials over 6 minus 2 factorials and 2 factorial way. Since n combination, remember we have n combination r based on the formula equal to n factorial over n minus r factorial and r factorial way. That is the formula for combination. So that is how we arrive at this. If our n is 6, you have 6 factorial, 6 minus this. Our r is 2, 6 minus 2 factorial, and r 2 factorial way. Multiply by 1 over, no, 1 square is 1, 2 square is 4, 1 over 4 into, this is 1 over 2 raised to power, no, this one, 6 minus 2, that is 4. 6 factorial over 6 minus 2, that is 4 factorial, and 2 factorial ways. Multiply by 1 over 4 times 1 raised to power 4 is 1, and 2 raised to power 4 is 16, which is 2 times 2 times 2 times 2. That's how I got 16, 2 raised to power 4. No, 2 times 2 is 4, 4 times 2, 8, 8 times 2 is 16. That's how I got 16. Now, 6 factorial is the same as 6 times 5 times 4 factorial. Since we have 4 factorial in the denominator, so we may choose to stop at 4 factorial over 4 factorial times 2 factorial is 2 times 1 times 1 over 4 times 1 over 16. If 4 factorial cancel 4 factorial, you'll be left with 6 times 5. 6 times 5 over 2 times 1, which is 2, times 1 times 1, 1 over 4 times 16. 4 times 16, that gives us 64 over 64. So, 6 times 5, 30. 30 times 1, 30. So we have 30 over, no, 6 times 5, 30. 30 times 1, 30. Over 2 times 64, 128. 30 divided by 128. 30 divided by 128. We have is 0.2343. That is probability of having exactly 2 heads. Probability of having exactly 2 heads equals to 0.2343. That is the solution to the example 1. Example 2. The probability that an entering college student will graduate is 0.4. Determine the probability that out of 5 students, 1, none, 2, 1, 3, at least 1 will graduate. Now let's have the solution. Solution. The probability of success P is 0.4. Since you were told that the probability that an entering college student will graduate is 0.4. If probability of success is 0.4, Q will be 1 minus P, which is 1 minus 0.4. Therefore, Q will be 0.6. Determine the probability that out of 5 students, the number of students, our n is 5. N is 5. 1, none will graduate. Now let's have the solution to number 1. If none graduate, probability that none will graduate, probability of x is n combination x into p raised to power x, q raised to power n minus x. If none will graduate, that means x, none. X is 0. If none is 0. Equals to n, our n is 5. 5 combination x, which is 0, and p is 0.4. raised to power x, our x is 0, and q is 0.6 raised to power n minus x. N is 5 minus is 0. So 5 combination is 0, that is 5 factorial over 5 minus is 0. 5 minus is 0 is 5 factorial and is 0 factorial's way. Remember, I've told you that 0 factorial is 1. If you have watched my earlier presentation of permutation and combination, 0 factorial is 1 times 0.4 raised to pi 0. N raised to pi 0 is 1 times 0.6 raised to power 5 raised to 5 minus 1. 5 minus is 0, that is 5. 5 factorial, if this is 1, 5 factorial over 5 factorial, that is 1 times 1. This is the whole of this is 1 times 1. Since 0 factorial is 1, the whole of this is 1 times 1 times 0.6 raised to power 5. So if you have a 0.6 raised to power 5, that gives us 0.07776 times 1 times 1, it will still be the same. Therefore, probability that s equal to 0 you have is 0.07776. That is the solution to the first part of the question. Now, Roman figure 2. If 1 will graduate, that means your x equal to 1. Probability of having x equals to 1. Let's substitute into the same formula. N is 5. 5 combination x is 1. P is 0.4. 0.4 raised to power x. Our x is 1. Q is 0.6 raised to power n minus x. Our n is 5 minus x, s is 1. So 5 combination 1, we have 5 factorial over 5 minus 1, which is 4 factorial, and 1 factorial's way. Multiply by 0.4 raised to power 1, which is still the same, times 0.6 raised to power 5 minus 1, that is 4. 5, this is the same as 5 times 4 factorial over 4 factorial, and 1 factorial is 1. So I might decide not to write that. Times 0.4 times 0.6 raised to power 4. That gives us 0.1296. 0.6 raised to power 4. 0.1296 times, if 4 factorial cancel 4 factorial, you'll be left with 5 times 0.4 times 0.1296. Now let's multiply. Times 4 times 5. The product of this is 0.2592. Therefore, probability of x equal to 1 is equal to 0.2596. That is the solution to Roman figure 2. Roman figure 3 now. Probability of having at least one graduate. If at least one will graduate, at least one means not less than 1. That means you may have 1, you may have 2, you may have 3, you may have 4, and you may have 5. 1, 2, 3, 4, 5. The sum of all the 5 different probabilities will give you the answer to this. But instead of you taking that long journey, you might say probability of x is greater than or equals to 1. That is, at least 1 will graduate. It will be equal to 1 minus probability of if none graduate. So, which is 1 minus if none graduate, s equal to 0. Probability of s equal to 0 is 0.07776. So 0.07776. Let's subtract that. 1 minus 0.07776. So therefore, probability of s greater than equals to 1 equal to 0.92224. That is the solution to the top part of the question. Alternatively, since you have found the probability of x equal to 1 here, you can as well find probability of x equal to 2, probability of x equal to 3, probability of x equal to 4, and probability of x equal to 5. Now, let's find probability of x equal to 2 and sum them up. If you add up probability of x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. If you add the 5 probabilities, it will give you the same answer with this. Now, let's confirm that. Probability of x equal to 2. Since you have solved for x equal to 1, using the formula is 5 combination 2, p is 0.4, raised to power x, x is 2, and q is 0.6, raised to power n, n is 5, minus x, 5 minus 2, which is 3. So, 5 combination 2 is 5 factorial. Let's evaluate 5 combination 2. 5 factorial, 3 factorial, 2 factorial, times 4 square, 0.4 square, times 0.6 raised to power 3. So, 5 times 4 divided by 2. 5 combination 2 is 10. So, we have 10 times 0.4 square, 0.4 square, that is 0.16 times 0.6 raised to power 3. That gives us 0.216. Now let's multiply. Therefore, probability of x equal to 2, exactly 2s. So let's multiply times 0.16 times 10. This gives us 0.3456. Now, let's also solve for probability of x equal to 3. So, which is 5 combination 3 into 0.4 raised to power 3 and 0.6 raised to power 5 minus 3, that is 2. Which is 5 factorial over 3 factorials, 2 factorial. So, which is 5 factorial, 5 times 4 divided by 2. 5 combination 3, that is 10 as well, times 0.4 raised to power 3. That gives us 0.064 times 0.6 square. That gives us 0.36. Then multiply them out. Therefore, probability of x equal to 3 equal to times 0.64 times 10. That gives us 10 times 0.064 times 0.36. This gives us 0.2304. That is probability of x equal to 3. Let's also solve for probability of x equal to 4. Probability of x equal to 4. That will be 5 combination 4. P is 0.4 raised to power 4. Q is 0.6 raised to power 5 minus 4, which is 1. 5 combination 4. 5 factorial over 4 factorial. That is 5 times 0.4 raised to power 4. That gives us 0.0256 times 0.6. 0.6 raised to power 1 is 0.6. Let's multiply them out. Therefore, probability of x equal to 4 equals to 0.0768. Then the next one is to find the probability of having of x equals to 5. Probability of x equals to 5 now. Probability of x equals to 5. No, this is alternative solution to this very one. This very one. If you don't want to do it this way, you can follow the latter solution. So probability of x equals to 5, that is 5 combination 5. P is 0.4 raised to power 5. Q is 0.6 raised to power n minus x. 5 minus 5, which is 0. 5 minus 5 is 0. So 5 combination 5 factorial over 5 factorial, that is 1. 5 combination 5 is 1 times 0.4 raised to power 5. That gives us 0.01024 times 0.6 raised to power 0 is 1. Then multiply them out. Therefore, probability of x equals to 5. That is 0.01024. Now, you want to find the probability of x greater than or equals to 1, which will be probability of x equals to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4 plus probability of x equals to 5. Probability of x equal to 1. Probability of x equal to 1, and that gives us 0.2592. 0.2592 plus probability of x equal to 2. X equal to 2. Probability of x equal to 2. That is 0.3456. 0.3456 plus probability of x equal to 3. Probability of x equal to 3, we got 0.2304. 0.2304. That is probability of x equal to 3. 0.2304 plus probability of x equal to 4. Probability of x equals to 4, we got 0.0768. 0.0768. 0.0768 plus probability of x equals to 5. Probability of x equal to 5, we got 0.01024. Probability of x equal to 5, 0.01024. 0.01024. Now let's sum it up. Let's add everything. 0.2592 plus 0.3456 plus 0.2304 plus 0.0768 plus 0.01024. That is totaled 0.92224. Probability of x greater than or equal to 1 equal to 0.92224. If you compare with what was obtained from our earlier solution here, you will discover that we've obtained the same answer, 0.92224, which is the same with what was obtained here. That is the end of the solution to the question. Please don't forget to like the video, also share it with others. Subscribe so that you don't miss my upcoming videos. Thanks for watching. In my next video, I will examine Poisson probability distribution.